Hey guys, it's Miss Richardson. Thank you for watching my video. There's a lot that's on it today. I'm sorry I couldn't be live in class today. I'll be back tomorrow, so let me know if you need any help. But what we're going to do today is compare functions. There's a whole lot in this video, so you guys need to watch the whole thing. Make sure you're taking notes and you are following along with me. All right, so we're going to start here on this very first page. We're going to compare these two functions. One thing we can do is take these ordered pairs and we can create a t-chart so that we can compare them easily since this one is also a t-chart. So what is this ordered pair right here? It's 0, 0. And then this ordered pair right here is 1, 6, 1, 6. All right, so if we find the change in y, so remember last unit we've said when we find the rate of change, it's always the change in y over the change in x. So how does y change? It increases by 6. And how does x change? It increases by 1. So if we write the change in y over the change in x and we simplify it, we see that our rate of change is 6. So y, which is meters, for J, that looks like a G, but it's a Y equals 6 times the number of seconds. So now let's find Nathan's rate of change. So we're going to do our change in, if this was X and this is Y, we're going to do our change in Y over our change in X. So this increases by 5. This increases by 1. So 5 over 1. Nathan's rate of change is 5 times the number of seconds. But notice that Nathan at 0 seconds, he started on meter 4. So he didn't start at 0. He didn't start at the beginning or the beginning banner thing. He started 4 meters beyond it, but Jay started at 0. So even though at the beginning Nathan is farther than Jay actually is running faster. He has a greater rate of change. So whatever number is being multiplied by X, that's our rate of change. And so by finding the rate of change for Jay and Nathan, we find out that Jay has a greater rate of change. He's actually running faster than Nathan. So these are the standards that we're going to talk about today. Here are our learning targets. Make sure you pay attention to the whole slide deck. There's a lot of information on this that you have to know today. All right, so if you need a review on the slide deck, go back and watch this video. It talks about how to tell if there's a relation is a function. Also, it helps you identify the domain, which is the x values or the input, and the range, which are the y values or the output. All right, so here we have different representations of the same function. So here we have a verbal expression, add 1 to each number. Here we have an equation. The value of y is you get the value of y by whatever x is, adding 1 to it. We can take that equation, we can turn it into a chart. So if x is 0, 0 plus 1 is 1. If x is 1, 1 plus 1 is 2. If x is 2, 2 plus 1 is 3. So these all represent the same thing. And then we can take these ordered pairs and we can graph them. So here we have the ordered pair 0, 1. Here we have the ordered pair 1, 2, 2, 3, so on and so forth. So all of these things represent the same thing. What representations have we talked about that are missing? Well, they don't have a picture of a mapping diagram, and they haven't actually written out the ordered pair, so those are the two representations that are missing. All right, so we can compare functions. It says the representations at the right represent the same function. All right, so let's verify that that is true. So we're going to take these ordered pairs that are graphed here, like these, for example. All right, so what is this ordered pair? So if we start at the origin, we do not go right or left. Let's make a t-chart. We don't go right or left, so our x is 0. We would go down 2. So this ordered pair would be 0, negative 2. This ordered pair would be 2, 2. When x is 2, y is 2. And then here, if we go right 4, up 6, so the next is 4, 6. So that's all of our ordered pairs, right? 0, -2, 0, -2, 2, 2. Here it is again, and 4, 6. Here it is again. So we've shown that all three of these represent the same function. Yep, they do. Does that make sense? All right, what if they represent different functions? How do we compare them? So let's write out there. Here's a mapping diagram. So our first ordered pair would be 0, 2. Our second one is 2 goes with 2. And then 4 also goes with 2. So that's not what this says, right? No, actually it is. Just kidding. So these ordered pairs match these ordered pairs, which means the mapping diagram and the ordered pairs go together. However, this is not the same as the other two, and the first one's not the same as the other two. So this T-chart is different than these two. These are the same, and this is a different function. That's easy to tell, right? Yep, the mapping and the order pairs, we got it right. All right, what if there is an equation? How do we compare those? Well, the first one's not going to make an equation because the rate of change is different. So what I mean by that is if we find the change in y over the change in x, this is +4 and this is +2, right? But then to get from 2 to 2, that's a change of 0 over 2. So we can't write an equation since our rate of change is different. However, if we take these x values and we plug them into this equation, if we get the same y value that's on our table, then we know that these are the same. For example, if x is 0, if I plug in 0 for x, 2 times 0 is 0, and 0 minus 2 is -2. That's correct. What if x is +2? 2 times 2 is 4. 4 minus 2 is 2, so that one agrees. And what if x was 4? 4 times 2 is 8, and 8 minus 2 is 6. So we know now that this equation and this table represents the same function. All right, and that's exactly what they tell us to do. Substitute the x values to find the y values, and we already did that. We plugged in those x values, and we got the y values, same as our table. So we know our equation and our table is the same. That's right. All right, what about this equation? Does it go with this T-chart? Well, they're showing you right here. We're going to do the same thing. We're going to plug in x values into our equation. So let's look over here. If x is 0, what's 4 times 0? 0, and 0 plus 3 is 3. Then we can plug a 1 in. 1 times 4 is 4. 4 plus 3 is 7. Plug in a 2. 2 times 4 is 8. 8 plus 3 is 11. If we plug in 3, 3 times 4 is 12. 12 plus 3 is 15. So we know that this T-chart and this equation goes together. Yes, they represent the same function. All right, so I want you guys to verify whether these two are the same. You can fill in that T-chart and see if the order pairs match. You want to see if this mapping diagram and this equation are the same function. And you also want to see if this T-chart and this equation is the same. And one way you can do that is by making your own T-chart and seeing if your data matches what they give you. So pause the video, come back and check your answers with me. All right, so on the first one, if you plug in each of these values for x, -3 times 0 is 0. 0 plus 2 is 2. -3 times 1 is -3. -3 plus 2 is -1. 2 times -3 is -6. -6 plus 2 is -4. And if I plug in 3, -3 times 3 is -9, and -9 plus 2 is -7. So I just proved, because these ordered pairs match this T-chart, that these are the same function. All right, so if I plug in, let me go ahead and plug in -1 for x. I know 5 times -1 is -5, and -1 minus 3 is -8. Well, I can stop right there because this tells me that when x is -1, y is 4, which is not what I just got. Okay, so I know these are not the same just by looking at that first digit for x. And then this one, this is saying y is equal to whatever x is squared. Okay, so if we plug in -1 for x, make sure you put that in parentheses. What's -1 squared? What's -1 times -1? That would be +1. What if I plugged in 0? 0 squared, 0 times 0 is 0. 1 squared, 1 times 1 is 1, and 2 squared, 2 times 2 is 4. So I can clearly see that these do not represent the same function, and I did that by making my own t-chart. All right, we can go from a table to an equation. Let's see how we're going to do that. How do we go from a table to an equation? All right, so the thing that makes up our equations is the pattern, also called the rate of change. So whatever the pattern is, that's what you're going to multiply by x, and then the 0 term. In other words, whatever y is when x is 0, that comes at the end of our equation. All right, so first of all, let's find our pattern. Our pattern in the change in y over change in x. It's always a change in y over the change in x. So how is y changing? From -2 to +2, we're increasing by 4. 2 to 6 would make us increase by 4. So our change in y is 4. What is our change in x? So 0 to 2, we would add 2. 2 to 4, we would add 2. So our change in x is 2. So can we simplify 4 divided by 2? 4 divided by 2 is 2. So our pattern or our rate of change is 2. So you're always going to multiply your rate of change by x. And then the 0 term. In other words, what is y when x is 0? Well, when x is 0, y is -2. So I can, plus a -2 is the same thing as writing 2x minus 2. This is the equation that goes with this table, and we're going to practice that more and more and more. So that was our first time. Don't get frustrated. Just make sure you do all of your examples with me. All right, there's our change in y over change in x. And then we want to know, so 4 over 2 simplifies to 2. And that's where we got our 2x from. 2 times x is the pattern. And then the 0 term right here, when x is 0, y is -2. There it is. And then when we simplify that, we get this equation, y equals 2x plus 2, or excuse me, 2x minus 2. And the good thing about after you write your equation, you can always check your answers. Take any of your x values, plug it into the equation. If x is 4, let's plug it into our equation and make sure it agrees with what we got. So 2 times 4 is 8, and 8 minus 2 is 6, and that's exactly what it should be according to our equation. So you can always check your answers on these. Yep. All right, we're going to use our template. We're going to put our pattern or our rate of change times x and our 0 term at the end. All right, let's take a look at this one. Let's look at our change in y, our pattern, change in y over change in x. All right, so how do we get from -3 to +2? On a number line, we're at -3. We would have to count forward 5 spaces to get to +2. From 2 to 7, we would have to increase by 5. And from 7 to 12, we would increase by 5. So our change in y is 5. And our change in x is +1, +1, +1. So can we simplify 5 over 1? 5 divided by 1 is 5. So our rate of change is 5. You always multiply that by x. Don't forget your x. And then they don't give us a 0 term. But if we work our way backwards, so 4, 3, 2, 1, this would be 0. And if we work our way backwards, from 12, we would subtract 5 to get 7, 7 minus 5 to get 2, 2 minus 5 to get -3, and -3 take away 5 would be -8. So our 0 term is -8. So this is our equation right here. Y is equal to 5 times x minus 8. We want to check it, plug in a value for X. 5 times 4 is 20, and 20 minus 8 is actually 12. So we know we are right. All right, I hope you guys are doing this with me. All right, so let's practice. We're not actually doing number 3. Don't worry about number 3, but I want you guys to see if you can figure out 1 and 2 by yourself and then check your answers with me. All right, so our equation is y equals something to do with x and then plus or minus a number. So how do we get that number that's multiplied by x? Is the pattern, change in y over change in x. How do we get from 8 to 14? We add 6. 14 to 20, we add 6. All right, so our change in y is 6. Our change in x is plus 1, plus 1, plus 1. So 6 divided by 1 is 6. Now, they don't give us a value of 0 for x, but based on the pattern, we can figure out what y is. So we go backwards 4, 3, 2, 1, 0. These we're subtracting 6 going up our column, 26, 20. 20 minus 6, 14. 14 minus 6 is 8. 8 minus 6 is 2. So the end of our equation is plus 2, 6x plus 2. Throw in a value here for x. 6 times 4 is 24, and 24 plus 2 is 26. So we know we are right. All right, number 2. We want our pattern times x, and then plus or minus a number. So how do we get from 4 back to 1? So on a number line, 4 to go to 1, we would subtract 3. 1 to get to negative 2, we would go left 3. And once again, we would subtract 3. So our change in y is negative 3. And then our change in x is plus 1, plus 1, plus 1. So can I simplify negative 3 divided by 1? Yep, I get negative 3. All right, so what if we make x 0 so we can find our pattern? 4, 3, 2, 1, 0. Negative 5 plus 3 is negative 2. Negative 2 plus 3 is 1. 1 plus 3 is 4. And 4 plus 3 is 7. So plus 7, that is our equation. Let's go ahead and plug in a 4 for x. So negative 3 times 4 is negative 12. And negative 12 plus 7 is, in fact, negative 5. So we know this equation is correct. All right, let's practice comparing these tutors. It looks like Mrs. Park and Mrs. Greer are tutors. Mrs. Greer's data is represented on the table. So let's see Mrs. Greer, G-R-I-E-R. And it says Ms. Parks is represented by this equation. The X value represents the number of hours, and the Y represents how many total dollars they charge. The question is, who will have more money in 4 hours? All right, so let's figure out Ms. Greer's rate. How is she figuring out her rate? Well, we can see the change in Y is plus 50, plus 50, plus 50. Our change in x is plus 1, plus 1, plus 1. So 50 divided by 1 is 50 times x. And then if we go down to 0, our y, if we take away 50, our y is actually 0 too. So we could put plus 0, but we do not need to write that because adding 0 to anything doesn't change anything, right? So Mrs. Greer is simply charging $50 per hour because the x represents, hours. So 1 hour, she made $50. 2 hours, she made $100, so on and so forth. Now, Ms. Park, we can make a T-chart for her as well. Let's say we start at 0. 0 times 25 is 0, and 0 plus 50 is 50. So it looks like she has a fee plus she has a rate per hour. So rate per hour is $25 per hour. Plus she charges a $50 fee. So for 1 hour, 1 times 25 is 25, and 25 plus 50 is $75. So far, Ms. Park's making more. In 1 hour, she made more money than Ms. Greer. All right, what about 2 hours? 2 hours would be 2 times 25 is 50. 50 plus 50 is 100. So in 2 hours, they make the same, right? You see that? They make the same amount of money. It asks, what about 4 hours? Well, in 4 hours, 4 times 25 is 100, and 100 plus 50 is 150. So that's interesting that Miss Greer in 4 hours makes more than Miss Park, but Miss Park makes more to start with, right? For the first hour, she makes more. Second hour, they make the same. And then Miss Greer is going to be making more money for 3 hours plus more. Okie dokie. All righty. So we'll move on. All right, we're going to practice finding our rate of change of graphs like this one, tables and scenarios. All right, so let's look at this graph right here. We're going to still find our rate of change, the change in y over the change in x. So we're looking for some coordinates that line goes directly through. So we can make our t-chart. What is this coordinate right here? When x is 0, y is -3. When x is 1, y is 0. When x is 1, y is 0. And when x is 2, y is 3. All right, let's just practice writing our equation. What is our change in y? We're adding 3, and this is +1, so 3 over 1 is 3. 3 times x, that's our rate of change. And then remember, the rest of our equation is what y is when x is 0, so this is our equation. So our rate of change is 3 for this graph. Let's look at some other ones. I hope you guys are practicing these with me. All right, what is the rate of change? All right, well, let's see. Let's write down these coordinates. This coordinate is 1, 2. And this coordinate right here is 5, 5. All right, so if this is x and the second one is y, so what is our change in y? 2 to 5 is +3, and 1 to 5 is +4. So our change in y is 3, our change in our x is 4. So our change in y, our rate of change is actually a fraction. That's totally fine. We get fractions, no problem. We could also write it as a decimal. All right, let's find out this rate of change right here, or any of these would work. All right, so what is this coordinate? Let's just do our 0, 2 coordinate, 0, 2. And this coordinate is 2, 3. All right, let's do our change. Remember, guys, it's always y over x. What's our change in y? +1. And our change in x is +2. So our change in y is 1. Our change in x is 2. So our change in y is 1/2, or same thing as 0.5. So far, this one right here has the greater rate of change. 75 cents is more than 50 cents, right? All right, let's look at the last one on this page. Let's write our coordinates. What's this coordinate right here? Whoops, I didn't mean to do that. Sorry. This coordinate right here is 0, 3. And this coordinate right here is 3, 1. So what is our change in y? Our change in y, from 3 to 1, we go back to -2 over +3. So our rate of change is -2/3. Now, -2/3 will be 0.66666. So that rate of change, so we always take the absolute value, even if it's a negative number, our rate of change you would think of as a positive number. So 0.666 is greater than 0.5, but this one has the greatest rate of change. It's the greatest rate of change. All right, so on this one, we're gonna go up to right 1. So our rate of change on this one is 2. If we did our change in y over change in x, it's always going to be a right triangle. So we would go up to right 1. So it's rise over run. So our rate of change of the first one is 2. So our rate of change is 2. All right, what about this one? Our change in y is +7 +7 +7 over 1 +1 plus, that makes it easy when our x is increasing by 1 because our rate of change is 7. Can you guys figure out the rate of change of the next few? I think there's several on this page. All right, so what is our rate of change to the next table? +4 +4 over +1 +1. Our rate of change is 4. And then the equations was easy because it's always the number multiplied by x. The rate of change here is 3. The rate of change of this one is 5. This one has a negative rate of change, but if you think of the absolute value of -10 is +10. So this one out of all of these on this page has the greatest rate of change. This one has the greatest rate of change. The absolute value of -10 is 10, and that is bigger than the rest of the numbers. All right, guys. So we've been practicing writing equations in this form. It's called slope-intercept form, where m is our change in y over x, and our letter b is what they call it in algebra. That is what y is when x equals 0. What y is when x equals 0. All right, so let's look how Michael charges his customers. So at 0 hours, he charges $35 because it costs a lot of money and time to get your supplies together and drive to a customer's house. You have the gasoline, you have the lawnmower, so on and so forth. And then it looks like he charges, what is our rate of change? +5 +5 +5 over +1 +1 +1. So his rate is actually only $5 per hour, plus everyone pays the $35 fee, because even at 0 hours, you still have to pay $35. So that makes that $35 a fee. So let's look at some more scenarios. So we're going to write equations for these scenarios, and then with words, we're going to write what x represents and what y represents. Anytime you have those questions, you're never going to answer with a number. You're always going to answer with words. So what you want to do to find your rate of change is you're always going to look for the word per something, per mile, per month, per whatever, per birthday, whatever it is. That's going to go along with your x variable. Y always represents a total. Y always represents the total of whatever we're talking about. Here we're talking about money, right? This, you're looking for the words per or for every. Those are the words that's going to help you realize that's where your x goes. All right, the cost of riding in a taxi in New York City is 20 cents per mile. So we're going to multiply 20 cents times the number of miles, plus anytime you have a fee or anything else, that goes at the end. When x is 0, that's going to be your y value. So the total you're going to pay for your taxi, y is total. So this situation tells us that x represents what? The number of miles. We know how much the price per mile is. What we don't know is how many miles the person rode, and we don't know how much they were charged. So number of miles. And then y represents the total cost for the taxi. Since we're talking about money, it's total cost. All right, what's the next one? Sean already owns 16 baseball cards, so that's his initial value. This already, he owned them. And then he bought 4 more each month for every month, or 4 cards per month, right? So Y is going to be total what? What are we talking about here? Total baseball cards. So he's buying 4 per month, plus we have to include the 16 he started with. So what does X represent? How many months he's collecting them, number of months. And Y is the total, what? Total baseball cards. All right, so X is always going to be the number of something. You're always going to say it's the number of blank. What are we talking about? Months, number of miles, number of I don't know, whatever the scenario is. All right, next one. Oh, let me erase this. Kevin went on a diet and lost 2.5 pounds. What does it say? Per week. That's our rate of change, 2.5. When he started his diet, he weighed 205 pounds. How much did Kevin weigh, at the end of 8 weeks? Well, the total what? What are we talking about? His total weight. So we're going to go ahead and write y equals his total weight. Well, is he gaining weight or is he losing weight? He's losing weight. So since he's losing pounds, we're actually going to say our rate is negative 2.5 because it's decreasing by 2.5 per week. And what does X represent? The number of what? Number of weeks. And then we do have to include how much he started. What was his weight at the beginning? Plus 205. So now that we have our equation, we can answer this question. At the end of 8 weeks, in other words, if the number of weeks, X is 8, we would multiply 8 times negative 2.5, which is negative 20, and we would add that to 205, the beginning weight, and we would know at week 8, Kevin weighed 185 pounds. Good for you, Kevin. All right, and we can answer that question easily after we've written our equation. Sally had $200 in her savings account. When? At the beginning. That's her initial money she has in her savings account. She added 150, what does it say, more per month, every month. How much money was in Sally's account at the end of 12 months? All right, so Y, which is her total, what are we talking about? Total amount of money in her savings account. Well, since we see per month or more per every month, we're going to multiply 150 times X. And what does X represent? Number of what? What are we talking about? Number of months. And we have to include how much she started with. So we're going to add $200 to whatever this amount is. And so what does Y represent? The total money in her account. Okay. So now can we answer this question easily? Yeah, so if months is 12, X is 12, we would multiply 150 times 12, which is 1,800. We would add the 200 she started with, and we would see at the end of 12 months, she'd have $2,000 in the account. Good for Sally. Good for Sally. All right, so this is the last slide, and I want all of you to see if you can write the equations in the format Y equals whatever your rate of change is times X, and then plus or minus a number. I want all of you to practice all of these on this last slide, which is all of these. And then I want you to come back and check your answer. If you get them all right, you're awesome. And you are an expert at writing equations from tables. If not, you need to listen carefully and see what's going on. Why are you missing them? All right, so let's do the first one. The rate of change is change in Y over change in X. Every time these increase by 10 over 1, 10 over 1. So our rate of change is 10. And our zero pair is when X is 0, Y is positive 7. So the first one is Y equals 10X plus 7. All right, the second one, how are these changing? If we're on negative 9, and we go back to negative 11, that means we would go minus 2, minus 2, minus 2 over plus 1, plus 1, plus 1. So our rate of change is negative 2 times X. And then that 0 term is minus 9. So Y equals negative 2X minus 9. All right, they don't give us the 0 values anymore, but we can figure out what those are. But first, let's do our rate of change. So this is plus 2, plus 2, plus 2. This is also plus 2, plus 2, plus 2. So 2 over 2 is 1. So our rate of change is 1. And then based on this pattern, if we go back, we would go down to 0. We would go 8, 6, 4, 2. So our rate of change, our 0 pair or 0 value is 2. And if I simplify 1 times X, I just get X, X plus 2. And that is our equation, X plus 2. On this one, we're increasing by 4 plus 4 plus 4. This is plus 2 plus 2 plus 2. So what's 4 over 2? 4 over 2 is positive 2. So our rate of change is 2 times x. And if we went down 2 values, got to 0, if we decrease by 4, by 4, by 4, by 4, this is going to be 16. And that is our equation for this one. The next one, our change in y is plus 3, plus 3, plus 3, over plus 1, plus 1, plus 1. So what's 3 over 1? 3 over 1 is 3x. And then if we went down one value to 0, these are decreasing by 3, minus 3, minus 3. So it's actually, we could write plus 0, but we don't need to do that. So our equation is simply y equals 3x. And that one's easy because isn't 3 times 5, 15, and 3 times 4 is 12, and 3 times 3 is 9. And then our last one, these numbers are increasing by 2 plus 2 plus 2 over 1. So 2 over 1 is 2. And then if we went down to 0, follow the pattern, minus 2, minus 2, minus 2, this is 5. So our equation is 2x minus 5. Did you get them all right? And based on all of these equations, if we were asked which of these, all of these have the greatest rate of change, it would be the first one. 10 is the biggest number for the rate of change on this page. All right, guys, so I know that was a lot. I hope you guys were able to hang in there with me. You took some notes. You did all these practice problems with me. And I will check on you guys tomorrow. I hope everyone has a great day. And I will see you guys later.